This is a Picard iterative algorithm defined by Picard in 1890. Okay. So, it is a self map, and x1 is an initial approximation, then a sequence is generated by xn plus 1 equal to txn, right, n equal to 1 2 3, and this is just the condition of contraction mapping, right. So, here we take this example, t defined on this closed interval 0 to 10 and defined by this tx equal to x by 3, then obviously t is a contraction mapping, right, with contraction constant 1 by 3, and obviously 0 is the fixed point of t, right. Then how will we compute it by MATLAB? So, in the next slide we will see the graph of the convergence of Picard iterative method for this example, right. So, first this is the MATLAB code, right, for Picard iterative algorithm. So, here all basic things already discussed by Dr. Asif sir. Here CLC means clear the command window, right. Here we take n equal to 20 number of iterations. So, and this is x1 equal to 5 initial approximation we take, because this is the iteration. So, we take initial approximation here, and here we will use a loop, and we use here very simple loop, for loop, right. This is for I equal to 2 to n plus 1, because x1 we already assigned here, initial approximation, correct. And we define here our function, because tx equal to x by 3 in the example. So, this is we take here t x I minus 1 is x I minus 1 by 3, and this is the Picard sequence x I equal to t x I minus 1, or x n plus 1 equal to t x n, right, and this is loop is end here, correct. And this is how to save this data in our computer to use in the LaTeX or our paper. So, here we create a file, right, FID is file open, here we write the name Picard, but one thing is remember that this name should be the same as your m file name. अगर आपने m file को m name दिया है तो यहाँ भी same name, you will give the same name Picard here. So, this the text file will be created here, and we want to print these all approximations here. So, we write here again a loop for I equal to 1 to n plus 1, because we also want to print x1 equal to 5. So, here we run it is from 1 to n plus 1, right. F print f, this is for display the results, you know, and this is f print f FID. Here something is missing, because this PPT is created in LaTeX. So, comment is not working here, right. If we do the comment, then that thing is not appear here, right. So, I will display that thing in the MATLAB, what is missing here. See this one, fprintf, this is the file name. No, this is percent means here we want to total 10 digits up to 6 decimal places, right, and this is for new line \n, and we want to print the values of xi, right, and this is file is closed. So, this is the MATLAB code for Picard iterative algorithm. So, now this is the graph. Here we will see that Picard iterative algorithm converges to the fixed point of the given mapping Tx equal to x y 3, 0 is the fixed point. So, this is converge at the fixed point 0, right. So, we create this graph by using the MATLAB. So, how to draw this graph? Just one more command, plot x. If we give the plot x, then all the results will be plotted in this graph. Right. And yeah, we will discuss in the next slide. I just put it here graph only. We also make the tables. Now, second example is In the morning, Javi sir already explained Picard iterative algorithm converges to fixed points of the contraction mapping. If mapping is non-expansive, then Picard iterative algorithm may or may not be converged, right? So this is another example here. Here T is defined on closed interval 0, 1. This is defined by 1 minus x. Then obviously T is non-expansive mapping, and 1 by 2 is the fixed point of this map, right? So now question is that can we compute it by Picard iteration method, or Picard iteration method converge to that fixed point? So answer is no, right? We will see here. Picard iterative method does not converge to the fixed point. That fixed point 1 by 2, it oscillates between 0 to 1, 0 to 1, 0 to 1, right? So we will see it by MatLab, right? So after that, Mann iterative algorithm, it is came in the literature in 1953, right? So here Mann iterative process is defined in this way. This is just convex combination of xn and its image, right? Where n is any control sequence that control the convergence, right? If an bigger than greater than 1, then converge is this sequence does not converge, right? So for the same example here, Tx equal to 1 minus x, this is a non-expansive map. Can we compute it by Mann iteration method? So answer is yes, we can compute it by Mann iteration process. So this is the MATLAB code for Mann iterative algorithm. So all things are same here as in the Picard iterative method, right? So here just we write the either Mann sequence xi equal to 1 minus a, this is star for multiplication, xi minus 1 plus a star txi minus 1, correct? So all things are here same. So this is the convergence of the sequence defined by Mann iterative method for the same example, means 1 minus x. 1 by 2 was the fixed point of that mapping. So Mann sequence converges to the fixed point of that mapping, that is converges to 1 by 2. We will see here, right? This is the convergence of the sequence to 1 by 2. Okay. So before that, now how it all works in the MATLAB. So we will see in the MATLAB here. Okay. So this is the code of MATLAB code for Picard iterative algorithm, right? CLC, I wrote all things here, what it's mean, CLC, number of iteration, that all things. So if you will change the initial approximation, or it is Picard. So your initial approximation is 1. If you will change 1, and what are the results? So I created a text file and I already opened here, that is the Picard text. This is the text file. So all results presented here, and these results will be saved in your computer or in your hard disk. You can use these results in your paper or in the text studio or latex file, right? So here we take when we run this program, you will get these results, right? So initial approximation is 1. So look here, initial approximation is, this is the initial approximation 1, that is 10.6 means up to 6 decimal places. So here up to 6 decimal places. If you want to change the decimal places, you put there 10.8, 10.10, 10.12 as your need, right? This is the second approximation, x2. This is the x3, x4, x5. So this sequence converges at up to in 15 iterations. After 15 iterations, Picard iterative sequence converges to the fixed point, right? So if we change here x1 equal to suppose 5, right, and I am running here the program, this one. So change the folder, you will see the change here in the this one. Now initial approximation is 5, second approximation 1.66, third and 4, and all are things. If you want to change the number of iterations, so change here n equal to here 60 is given, you will take n equal to 20 like that and run that program. So this one you will get the results here, only 21 results. Right. So this is clear to all students or all the participants. Okay. So now if you want to plot these values in a graph, I just give the command plot x. We want to plot the all values of x here and then run this program. You will get the graph here, right? This one. Okay. Similarly, for man iterative algorithm here, because in the man here this is the control sequence I just denoted by A, right. So first we assign the value of A, and Asif sir already explained these all things. So this is the man. Now here the convergence of the man iterative algorithm depends on this control sequence as well as initial approximation, right. If we change here, first look the results here. Initial approximation is 1, second, third, fourth approximation, that will converge in 21 iterations. Number of iterations are 21. If I will change the first this control sequence, here the value of control sequence is taken 0.8. If I will change here 0.2, then what happened here? First I run the program, you will see the results here. Now it will converge in more than 60, so I will change here. Not on 80, more than 80 iterations. More than 90, so 100. More than 100 also. Yeah. It converges in 103 iterations. When I change the control sequence only, the rate of convergence depends also in the control sequence, right. So that's why the rate of convergence of man iterative algorithm slower than the Picard iterative algorithm, because there is no control sequence in the Picard iteration process. But why we need, you already seen here, why we need a man, because Picard iterative algorithm does not converge to fixed point of non-expansive or larger class, non-expansive mapping or larger class of mappings. That's why we need the man types iterative algorithm, right. So if I will change, I think the initial approximation, that also affects to the rate of convergence. I will put here, I think 5. So look the results here. Yeah. 106. If we will change A equal to close to 1, the rate is faster. Okay. Suppose it is 0.99. Then what happened here? Look this one. It converges only in 16 iterations. right. So this is because contraction mapping. I will change here function, right, non-expansive map I have taken there in the example 1 minus x, right, and taking the initial approximation 1 or 0.1 or 0.9 as well. So first we take 1, and here taking a number of iterations are 60. Now run this program. Not converges to also not converge on the 100 iterations. If I will change the a like 0.8, yeah, then converges only in 29 iterations. If I will change 0.2, then converges in 29 iterations. So in this example, we will see that when a is smaller, then rate of convergence is fast. In the previous example, a is larger, then convergence is fast. So this is the, I think, still open problem, how to find the optimal choice of the control sequences. This is still open, because all the authors taken arbitrary values of the control sequences in the interval 0, 1, right. How to choose the optimal values of the control sequences. So again, if I want to plot this one, so I put it the command here, plot x. So look here, it's taken 100 iterations, so I think this there. Okay, so this is the graph. So here man sequence converges to the fixed point 1 by 2 of the mapping 1 minus x here, right. So one more thing, how to compare these two iterative algorithm or more than two iterative algorithm in a single graph, right. So here that is a program of that one. Look here, this one. So for this you will take the same mapping, same space, means same domain for both the iterations here. So I will take here number of iterations 20, initial approximation 1, and mapping is x by 3, which is a contraction, right. So here I wrote here first Picard iteration method, which is given by this loop, for loop txi. First this is the mapping and xi equal to txi minus 1 Picard sequence, and this is the man iteration method here. So I will take here a equal to 0.8 x1 1 equal to 1. This is the for loop for man iterative algorithm. Okay, here I said all things means a1 means here plot x. X is the sequence of Picard iteration here, x equal to txi minus 1, and I said here all things here, color is blue, line is means smooth line, this is the marker size is cross, and it is size is marker is cross, size is 10, line width is 2. I have already said all things here, and hold on command for second figure. So a2 is Here plot x1. X1 is the sequence of man, right? This one x1 equal to I. This one x1 1 minus a. This is x1. I change here x2 x1. So I said already all things here for man also. And x1 we want to plot x1 color r. No, line is smooth line. S means is square. Marker is square. Size is 10. Line width is 2. And legend here I given Picard and Man because I am comparing two Picard and Man, and this is if we want to box off legend, then write box on. If I want to box off, so I wrote here box off of the legend. Here label x level means on the x axis number of iterations, and on the y axis y level value of x will be presented. Right now I run this graph or this program. So I think this is the error in this MATLAB, not in the program. So I put it here 60. Also error. Yeah. This one. So you will see here all things value of x n on the y axis, number of iterations on the x axis. These are our legends. We are comparing here Picard and Man, right? And this is the graph or comparison of these two ones. So here also we can see Picard sequence converges faster than the Man. Right, you will see the graph here. This is blue line denotes the graph of Picard, and red line denotes the graph of Man. So in this way you will give the comparison. Okay. So now with the help of these two programs, you may create more programs. MATLAB code for Ishikawa, Noor, as well as all our iteration methods, right? So now this is the problem for all of you. Please try it yourself in your computer, laptop, or as well in the MATLAB. Here you will create a MATLAB code for first Picard iterative algorithm and then Man for this mapping. So here it is sin x by 2. So obviously this is a contraction map to Picard iterative algorithm converges to the fixed point. And what is the fixed point of this map? In this interval 0 to 1, 0 obviously 0 is the fixed point. So please create the MATLAB code for this question.
Okay. Dr. Fahim, if you have any question, Perry,
Last.
maybe you can ask.
Oh, thank you.
So this is just simple examples. So after that, you people can start creating your own examples and on basically code for the different class of the or you can different fixed point algorithms. Not because these are simple, but in the signal processing, image processing, they are a little bit difficult. But they are not difficult, of course. But little bit you have to do some effort. So you can do. So for now I thanks to speaker of the afternoon, Dr. Asif and Dr. Fahim. They give nice idea on MATLAB and this expression on the fixed point algorithm in view of the MATLAB program. So let us see tomorrow, and maybe you can enjoy a little noise tonight, but not too much night because otherwise you cannot do that in the early morning tomorrow.
Okay. Thanks to all, and thank you, sir.
Late night maybe 1 a.m., 2 a.m. like that. Because program going on.
हाँ ठीक है.
But better to come by midnight.
अगर आप लोग फर्दर डिस्कस करना चाहते हैं तो अभी आप भी 2-3 दिन यहाँ पर हो या और आप कर सकते हो.